etc. Ας μαζευτούμε σιγά σιγά. Λίγο θα στα αγγλικά, οπότε υπομονή σας. Hello, I'm Sergio.
Hello. Yeah,
Welcome
can you hear me?
to VueJS Athens. This is the first meetup after COVID. Today is a special meetup because we have Evan Yu with us. Hello, Evan.
Hello.
Can you see us?
Yes. Yes.
Perfect. So we are here with Evan Yu, the creator of Vue and Vite, and we will start the meetup with a Q&A session. We will take questions from the audience and from the YouTuber as well. So, VueJS Athens, here is your chance. I mean, make your questions. Are there any questions for Evan? Yes.
I have wrote one. Hello, Evan.
Hello.
I have to check my question again. Sorry. So, something that we are interested about is what the features do you think that they need improvement in the near future of Vue?
Yeah, so this is a pretty big question. So there are several aspects, obviously, that we have plans for. The first is we want to stabilize some of the server-side. We want to improve some of the server-side rendering features that we've seen a lot of other frameworks have been exploring. For example, we see a new wave of these meta frameworks like Astral. They're exploring ways to reduce the initial JS payload, to reduce the cost of initial hydration when doing server-side rendering. So we believe there are a few ways we can do this in Vue core that can also be leveraged by meta frameworks like Nuxt. So that's one aspect. Improve SSR hydration. And the second aspect is we want to stabilize some of the features that we implemented in script setup. For example, like when using some of the macros with TypeScript, currently it has limitations on how it works with imported types, but we believe these can also be fixed in the upcoming version. And then there is the overall performance. We are exploring new ways to compile Vue templates. I've mentioned Vapor Mode in a few talks earlier this year. It is a experimentation that we've been working on that compiles Vue templates into something quite different. It no longer relies on the virtual DOM. It essentially outputs code that is specialized for the most optimized DOM initialization and updates. And in benchmarks, we're seeing greatly improved numbers and also smaller bundler sizes and all that. So this is a very promising direction. The challenge with this is how do we make it seamlessly adoptable in an existing V3 application, because we don't want this to be a breaking feature that you have to rewrite anything to opt in. We want it to just be allow you to be able to adopt this incrementally inside already working V3 app. So that is actually the main challenge that we're trying to solve right now.
Thank you very much, Evan.
Yeah.
Perfect. Any other questions for Evan? Come on, guys, don't be shy. Oh.
Hello from me, Evan. Before you mentioned the Astro framework, And I would like to ask you about your opinion and your prediction for the future of such frameworks that are new, like Astro, Quick, and other ones. What will be in the future the piece of cake that these frameworks will obtain in the relation with you?
To be honest, I think it's a little bit early to say. In general, I still feel that so each of these kind of have to be discussed separately, but in reality, I would still think frameworks like Next and Nuxt are the most versatile and versatile types of framework because they can do both static site generation, server side rendering. It also has backend aspects of it. So they're the most flexible type of frameworks that can be used to build almost anything. Whereas, so the first thing with Astro is that it is almost specialized for light interactivity, marketing type of applications. So once you start, so Astro is based on the idea of island architecture. So you only hydrate parts of your app, right? But it does not really prevent fat islands, so-called fat islands. So once you're inside island, it's still a full-on application. So if you use Astro to build a relatively complex app, it in fact would defeat most of the advantages that Astro brings in the first place. And then you're limited to the multi-page application architecture because so Nuxt and Next are still single-page applications. So once you hydrate the initial page, it becomes a single-page application. So after the initial hydration, all the subsequent navigations are extremely fast because the navigation, you've already paid the cost of most of the code, and on future navigations, you're just fetching new data and then rendering them dynamically most of the time. Whereas in frameworks like Astro is actually limited to multi-page applications, which means every time you navigate to a different page, it is actually loading a whole new page. So if you have, even if you lazy hydrate or hydrate with our islands, if your new page contains a lot of JavaScript, those JavaScript will need to be evaluated again. So you're repeatedly paying more cost on each page navigation. So there's a trade-off there. And I think it will fundamentally limit the use case for Astro, right? So it is better suited for static site like marketing pages, blog sites. But again, you can get equally nice performance with Nuxt 3, for example, for those pages as well by statically generating them. So so overall, I am a bit of skeptical with Astro's long-term viability because I think it still kind of fits in a relatively narrow niche compared to Nuxt or Next, where they can handle all kind of cases. And on the other hand, for Quick, I think Quick is interesting. It is still very, very early. The model that Quick opt to use is yet to be proven in more complex cases. Again, the common shared issue I see with these newer type of frameworks is that a lot of the claims about their performance are based on theory, but we haven't really seen any real world cases, real world complex apps built with these frameworks for us to actually benchmark and see like how well it actually does in practice. So there are interesting things we can definitely learn from them. But I think it's still quite early for us to tell whether these theories actually turn out to be, you know, to be doing what they should be doing in practice. So we'll wait and see. But like in the meanwhile, we're paying attention to see what good ideas we can learn from them.
Perfect. Thank you. So let's take some questions from YouTube. So Stefanos is asking, should we refactor a large-scale application from Vuex to Pinia using Vue 2?
So as with any type of migration, I think the first question you need to ask is, are you having trouble with the thing you're currently using? Right? If you don't feel like if you don't feel like it's actually hurting your productivity, then the cost of migrating may actually be not worth it, right? It's kind of like, so how do you tell if it's hurting your productivity? I feel like it's something like, do you need glasses? If you can't see clearly, you know you need glasses, right? So so the first question is make sure your current stack is actually hurting your productivity. And the second thing is the thing you're migrating to, whether it actually solves your problem. So one of the main advantages of Pinia over Vuex is type support. So if you are using TypeScript and you're having a lot of trouble with properly typing your state management code, I think then it is a really good reason to migrate to Pinia. But otherwise, yeah, so I think this is the main thing you need to look at, right? So I don't know more context about your app. So, but I think type support is probably one of the most important reasons to consider.
Nice. Thank you, Led. Any other questions from the audience? Yes, please.
Hello, Ivan. If it's possible to migrate one feature from React and one from Angular to Vue, what it would be, and not say Angular forms.
I guess right now, like I don't really see a strong need to migrate features from these frameworks. In many ways, some of the newer features in React, for example, concurrent mode or server components, they come with a lot of trade-offs that may or may not, that we feel that doesn't make too much sense for Vue. Like I can go into a lot of depth about this. I once wrote a pretty lengthy explanation on why we're not going to do concurrent mode in Vue. And similar for React Server Components, the reasoning is that server components are essentially more like an architecture instead of a feature of a library. It's more like enforcing a whole set of paradigm, like how you would build a meta framework around this feature. So it kind of enforces a whole architecture on you and couples your application to a Node.js server runtime. So these are kind of trade-offs that React has decided to do, but we don't feel that it's the right direction for us. So, and outside of that, we don't really see super important things that's missing per se in Vue from the React side. Because we support JSX as well. We support virtual DOM. So if people want to, if they want to, they can even write Vue in a React style. And I know some people do that. So from the Angular side, again, I think one of the nice things about Angular is probably just it's a whole set of a very opinionated structure together. But again, yeah, I think going back to the point is that framework design is not about adding features and putting them together. I think framework design is more about coherence, making sure the set of features stems from the same set of principles so that they make sense together, right? There are certain things that makes good sense in React and make good sense in Angular, but they don't necessarily make good sense in Vue. And in a way, this is also because, say, Angular caters to a quite different developer audience, to be honest, right? People who like Angular typically came from a Java background, and they are really familiar with how the whole class-based concepts, IOC or dependency injection, and it's natural for their mental model. So a lot of features they liking Angular doesn't necessarily make sense in Vue. So yeah, so I guess the short answer to your question is I don't really have any of those features in mind, but if you feel strongly that there are certain features that we should have in Vue that's in Angular or React, it would be interesting to discuss.
Nice. Leandros, would you like to ask?
Hi, Ivan. Nice to meet you as well. I do have a question for you regarding scope slots, which is one of the, I'd say one of the most important features in Vue 2 because of basically the ability that gave to composition. With composables, do you think that scope slots, like, it's coming to an end, or like, do you think that there's still ways to practice it? I do have something in mind, but like, I would like your opinion as well.
It definitely still has its place, but yes, composables will fill in a lot of the use cases where previously we some users may rely on scope slots to implement. So the difference is mostly between what you are encapsulating. Are you encapsulating pure logic, or are you encapsulating both logic and visual representation, or say DOM structures? So a good example is an example that I typically give is, for example, a component that abstracts away the logic of say a list component. So you want to give it a list of data and ask it to render a list of items. So this component will manage, say, pagination or pull to reload or infinite loading, this kind of advanced features. It will handle that for you. But at the same time, you also want to be able to customize how each item in the list looks, right? So you're trying to let the component encapsulate logic, but that logic is also coupled to a part of the DOM that you want to customize. So this is where scope slots still has, this is the perfect use case for scope slots, because the component encapsulates logic, but you still need to customize part of its DOM. But in other cases, for example, you're just abstracting away, say, some logic that has nothing to do with visual representation, then composable would be the better way to go, because it doesn't involve creating an extra component instance. So it's lighter weight. It's also, easier to author and test in a way, now that your logic in the composable is purely living in JavaScript or in TypeScript. So there's less hoops to jump through. Type inference also works more directly. Whereas through scope slots, sometimes it can be a bit of challenge to get the typing work through those scope slots.
Perfect. Thank you very much.
Yeah.
Thank you. And one last question from YouTube. So, what should we expect from Vue 4?
As of now, to be completely honest, there's no plan for Vue 4 because we feel that the 2 to 3 transition has caused a lot of disruption to the users, and we feel like we want to. So there's definitely a lot we learned from it, and we want to make sure that Vue 3 stays stable as long as possible, which is also why, even though we're researching, things like vapor mode, which is quite a big of a, it's kind of like changing the engine underneath in a way, but we still want to introduce in a way that's that can be 100% compatible with your current Vue 3 code. So in other words, we don't have plans for like big bang rewrites or big disruptive changes similar to the ones we had in Vue 3 anytime soon. Even if we end up doing Vue 4, it will probably be very small breaking changes, similar to those that you see in Angular major releases now. So, the difference between Angular 13 and 14 is probably not as big as Angular 1 and Angular 2. So even for major versions, the significance of the major versions can be quite different, and we kind of want to slowly sort of down level the significance of these version bumps, even for minor versions as well, because we've been holding up a lot of features with 3.3 just because we feel like we shouldn't ship new features in patch releases, right? So we're waiting for this whole big minor release to be ready before we can release it, but it ends up dragging on for a very long time and blocking some of the features that can already be shipped. So we want to sort of start changing the mindset a little bit, so we do more frequent and smaller minor releases, and also in the future when there are opportunities, we may release major versions, but these major versions may actually just be containing really, really small breaking changes. For example, removing some deprecations and stuff like that. So yeah, so in short, there's no plan for really, really big disruptive changes.
Perfect. Thank you so much.
Yeah.
I think we are out of time. Ivan, thank you so much for joining us.
Yeah.
Thank you for
Thanks,
being
everyone.
here.
Yeah. Hope you enjoy the talks later.
Take care. So, last question, really last question.
Okay.
Can we see you soon here in Athens, Greece?
Yeah, that's a tough question because it's kind of tough planning travel to Europe, because I'm in Singapore now and I have 2 little kids. So every time I make an international trip, I have to kind of plan a lot of things around it. Whether I need to bring family, do they actually, are the kids on vacation? Do they need to go to school? So there's a lot of variables I need to consider.
Yeah.
So yeah, unfortunately, I don't have a definitive answer for that. But I will. One thing confirmed is I'll be in Amsterdam next February. So there's the Vue Amsterdam going on, and it's going to be a big one. And yeah, if you're able to make it there, you can try to find me there. Otherwise, if we can manage to get a Vue conference to Athens, I've never been to Greece, so I do hope I can visit there one day. It's a little bit difficult for me to predict the plans for now.
Yeah. Okay. Thank you so much for your input. Thank you so much for being here with us. Everyone,
Thanks,
Evan,
everyone.
you. So,
Thank you, guys. Bye.
take care. Bye-bye. So, moving on, we have Leandros Kounadis from Kaizen Gaming, who will speak for us about architectural approach in large view scale applications. So,
Hello, everybody. So I hope everyone enjoyed that. I personally really, I couldn't wait for the day. And it's really glad that that you're all here. So without further ado, shall we start the share screen whenever we can? Cool. An architectural approach to large-scale VueJS applications. I'm actually pretty ecstatic with some of the things that Ivan shared with us, because he would have completely crippled my presentation at some point. So yeah, that's pretty good. So let's start. I think you need to change it to the actual slide. Okay, I think we're good. All right, so when we're thinking about a large-scale VueJS application, which we could put in brackets the Vue.js, because most of these practices can be, you can conform and you can use them in other types of frameworks, UI frameworks, of course. So just keep that in mind, and also throughout the presentation, everything that I do say is an opinionated way to large-scale application, not small ones, even though you can practice the exact same things. So the index of basically the whole presentation is, what are we trying to solve? The stack and the analysis, which is where we'll be spending most of our part on, and the project setup, what happens now. Yeah, sure. Usually I start with an icebreaker, but I brought one with me, so I'm sorry. Cool. So what we try, the main two things that large-scale applications face is modularity and scalability. Of course, there are many other things that we should be taking into consideration as well, like performance. But for this specific one, we're not going to be discussing performance that much, mostly because performance is not only the architecture as well, but there's more, far more other things that we need to do in order to achieve performance. So, thank God we're starting with Vue.js. Why? Well, because you can start small, but you can think big. And that is, it's pretty cool that we can do that with Vue.js. And again, you can do that with the frameworks, but this is a Vue.js one, so let's stick to that one. High-level breakdown. So when we're thinking about tackling a large-scale Vue.js application, more or less these questions come to mind, and we're going to be answering each and every one of them, and more or less the approach on reaching a final decision. So upper level framework, or else the meta frameworks, Vue 2 or Vue 3, since we're still in, we still have both. State management, strictly type, CSS frameworks, conventions, testing, and productivity tools are basically the topics which we'll be covering. At this point, the slide should have gone on. Okay, cool. So this part, I had quite a few things to say, but I'm not sure who asked the question about SSR. We got quite a bit of information. So yeah, when we are thinking about whether or not we should be using a meta framework like Astro or Vite with SSR or Nuxt.js, we need to take into account many things, and based on those things, we can reach a conclusion. Those things are mostly driven by the actual business itself. So if you are like leaning towards a more static generated, large, again, scale application, maybe Astro is a better approach. But if you're leaning towards a more of a dynamic website, which at least in this case we will be discussing, maybe it's not such a good option. As far as Vue 2 and Vue 3 is concerned, like Vue 2 is coming to the end of its life in the following year, so slowly this should be taken off the table completely. Why? Well, we know what Vue can do. All of those things that we've been using them for many years, I think 6 years now, and well, we were shifting to Vue 3. So this is no-brainer. Starting off a new application, you should be moving towards that one. But even if you haven't, and you already are in an application, a large application which does have Vue.js, you should slowly consider shifting towards the Vue 3 world. State management. Many people try to avoid state management. But at least for large-scale applications, state management is a crucial aspect. Well, the reason why is because, well, think about any large-scale application. Think of how many entities, modules, components, or other parts of the website it has. This is almost impossible in a scalable, modular, and easily debuggable way to actually develop. Think about it for a second. There is no real other way, at least right now, to tackle all of these issues. So using state management, you have a single source of truth for your whole state, which is the number one reason why we're using state management. The second reason is that by using state management, your state is predictable. You know what's going to happen. You can test it. You can debug it. You can even use the dev tools, which we'll be looking at later on, to time travel, to go through a whole timeline and try and understand what happened during this timeline and have X, Y, Z bugs. But most of all, this is where our business logic lies. Our business logic should not lie anywhere else other than the actual state management. The question to why only there will be answered later on. So I'm just popping just various questions out there, which will be answered as we move along. Since we're in the Vue world, we have two main competitors right now to start using with state management: Pinia and Vuex. And actually, this is where I'm really glad for one of the answers that I got from Ivan regarding Vuex and Pinia, because there are many large-scale applications out there which are using Vuex, and knowing the actual business, hard deadlines and stuff like that, making this transition from Vuex to Pinia is something which I'm not going to say is impossible, but it's quite difficult, especially if the store is, well, polluted with all sorts of things. However, do keep in mind that when I said before, if all our business logic is in one place, the transition from Vuex to Pinia can become far more easier. Why? Well, as I said, our business logic is in one place. And if we're using our state management correctly in Vuex, which means our actions, our getters are the only places where our logic lies, then the transition to Pinia is simply finding a way to remove the mutation. However, apart from these two great tools that we have at our disposal, and although it's clearly stated that as you're moving forward, do choose Pinia, like that's a no-brainer. There are other state management tools out there which are equally good, and they're framework agnostic. But why would anyone choose anything like that? Well, there are numerous reasons. Some of them could be that we're not tying ourselves to a specific framework, UI framework. Another one could be that we're fond of observables. My team knows observables. So if that is the case, maybe Vuex isn't a best option for you. And maybe Pinia isn't either. And we could look at Redux with Redux observables, or Mobex, again with observables. And again, there's other options out there. At the end of the day, though, you need to make a decision based on what you have, and your business will help you decide where you should be lying. Should you go with a trend, or should you go with something completely agnostic? Maybe you're thinking about switching UI frameworks and using the Redux state management, for example, as the the state management to have right now for our Vue application, but tomorrow we want to use Svelte, for example. Using one of the framework agnostic ones will help us do that. Whether or not you're creating a huge debt, that remains to be seen, but it is achievable because we are in the JavaScript world. So next slide. Sorry, the remote is a bit distant, I think. The next question that we need to answer ourselves is TypeScript, types. What should we do? Should we or shouldn't we? Well, right now, the options that we have when we're thinking about types, strictly typing our language, is TypeScript, of course, which has been with us for numerous years now, and Flow. However, the proposal for a native type annotation in JavaScript has been submitted, and hopefully within the next few years, we will be seeing it in native JavaScript as well. But why TypeScript? Like, what are we gaining? Well, there are a few areas that we will be gaining quite a bit, even though it may not be from day one. In actual fact, day one, people will most likely hate it if they've never ever worked with it before. They were saying that this is just an extra complexity added to the project. Where are we gaining and stuff like that? However, the real reason that TypeScript and libraries like Flow as well will really help us is with the last line, help with refactorings. Say we have two developers, same project, the only difference being that one is working with TypeScript, the other one isn't. They have the exact same tickets, they implement the exact same things, and at some point they need to resolve a bug or bugs, or they need to do something else or refactor something. The person who is working without TypeScript, if the refactoring touches things which is in numerous parts of the application and resolves around the contracts that could be breaking for whatever reason, that person will be struggling a lot. Whereas person number one with TypeScript, although he will struggle, like all the breaking changes will be clearly visible. He won't have to search for every single piece in the code and fear whether or not this refactoring will work, because he's type safety. There's another though area that TypeScript shines, and that is with contracts. Like, if anyone is familiar with TypeScript, they know that they can create their own types, and then they can assign them to their own classes or objects or wherever. But one area where TypeScript can really help us out is locking in and having a single source of truth in regards to contracts with the backend. This can come really easily when we're using tools like GraphQL, because it's just an export for them. And REST, you can do it, and basically within any kind of backend implementation which exposes the types to us, we can grab that. However, in cases where we don't have either of these, the most familiar way that backend guys can actually get their documentation of their contracts out there is tools like Swagger. And we can actually grab all our types directly from Swagger. We can export them and we can import them into our application. Why would we want to do that? Well, it's pretty simple. By doing this, you know that at any point in time, if anything changes on the back end, by adding a correct pipeline to a correct check to grab our TypeScript types from the backend using tools like Swagger TypeScript API. If anyone in the backend has broken something, has changed something, we'll know as soon as possible. We won't need to go to production and be afraid that something is broken. It'll be there in actual development. Next topic is CSS frameworks. So CSS frameworks are, well, so many. I have no idea how many there are. They're hundreds, I think. And each serve their purpose for whatever reason. However, even though there are so many out there, in large-scale applications, one of the most important things that we need to be able to do, and it just comes naturally at some point, because when I'm talking about a large-scale application, you most likely talking about a business which wants its own picture out there. So you're talking about something which needs to be highly customizable. So this option is given really easily to us using tools like Tailwind. Tailwind basically is a utility first driven approach CSS framework. If we look at the right hand side, we will see a ton of classes. Just have a look for a second and try to read what the code says. And if we look at line 21, there's no styles. There's nothing. Because the only thing that needs to be done is a good setup in the beginning, configure Tailwind according to your project, and then you can use all of these classes. Literally, imagine inline styling on steroids. That's what you're getting. So you need media queries, it has it. MD, flex. You need custom heights, you have it. You need specific weights on fonts, you have it. And everything you can imagine you can do with inline styles, you can do directly through this utility-driven approach. So we've reached the point where we've set up all our frameworks, our libraries, and more or less everything that we need is there. Does this mean we can start implementing? No, by no means. In actual fact, this is just the beginning. You've set up the tools for developers to use, but we still have a long way to go. Why? Well, the next part that we need to discuss thoroughly is conventions. Conventions is one of the things that will make a code base look either messy or intact. And the reason is that in these conventions, we have many automated ones and we have many manual ones. But many projects, due to time constraints, they remain on the second one. And in actual fact, they don't even remain on the second one because time isn't really given to enforce the first or the second. So code reviews go around. Everyone has his own opinion. And at the end of the day, it doesn't really matter because everyone has an opinion. I have an opinion. This is my opinion right now. Doesn't mean that it's right. It's his way, but it doesn't mean that it's right. But when you're working in a project, when you have multiple developers, when you have multiple teams, what you need to do, and it's really important, is this team or teams, or someone at least, to lay down what the automated convention should be and what the manual ones should be. More specifically, when we're talking about automated conventions, we're talking about things like linting, where we can code format our code, and code quality ones. Both are there to prevent developers spend time on things which are useless. And I'm not saying that having a certain format isn't is useless. What I'm saying is that having developers on many teams literally working or trying to fix even the simplest thing like a spacing, adding spacing or adding trailing commas or adding quotes or removing unused variables and stuff like that, that is useless. Why? Because we have tools. No developer should actually be working and removing these things by themselves. And that's why these tools, not only are they automated in pipelines and on some sort, they also should be integrated in our environment, our ID as well. And when we're talking about manual ones, we're mostly talking about style guides, which should be set at some point in time, most likely in the beginning. But this is also an important note that, and for the previous one, regarding automated ones, that the project, large-scale projects, usually are like a living organism. What does that mean? It means that it changes day by day. Needs change day by day. New packages are added day by day. Requirements are changing day by day. So even though these are set at some point in time, automated and manual modes, does not mean that that's it, it's written in stone. No. They were written in stone then when the team, the people decided that these are the right ways to proceed. But these should always be, you should always reiterate every so often and make sure, are these actually helping us? Are developers wasting their time doing things that they shouldn't be? And I'm not talking about reading something else on YouTube or anything. I'm talking about actually spending time on code coding things that they shouldn't be. And the next sore topic, testing. Testing and testing. I can't believe how many times I've heard the words, we have no time to test. Everyone's heard it, actually. If there's any developer in here, they've definitely heard that. We have no time to test. We need to get to production. So where do we start off? Let's forget about testing in terms of QA and automation testers. When we think about testing, we should be thinking about what can I do as a developer to prevent bugs going out to production and the quality of code being on par with what's expected of me. So whenever we give a review to a pull request, a merge request to anyone to review, usually, and actually I've done this myself, so it's not like I'm blaming anyone, because it's something that we do as developers, unfortunately. We just give it directly, like, let's say I'm done, I'm finished. I've written unit test, I've finished the implementation, take it. And the next part of the flow is the developer, another developer, picks it up and he starts reviewing it. There's a missing pipeline though here. And that is, as a developer, your responsibility is to take this ticket from the implementation part and get it into develop, master, release, whatever, with its quality, its implementation, all intact. That's the responsibility of the developer. It isn't the reviewers, it isn't the testers, it isn't the POs, it isn't the DLs, it isn't anyone else's, it's the developers. It was his ticket. So where do we start off? We start off by code reviewing our stuff. Before you submit the actual review to anyone, you review it yourself. Why? Well, okay, I've written it, so I was thinking like this, closed in when I was doing it. Okay, take 5 minutes off. Go back, look at it. There is no way you won't find at least one issue with it, at least, unless it's like a one-liner, which even there you should check it. It's impossible. So If you don't do this, what happens? Well, the next flow is, it goes to the code reviewer. The code reviewer picks it up, and he starts reviewing your ticket. He finds those issues that you should have found. So we've wasted his time because this was your work, my work. So I should have found that. He shouldn't have found it. And once that is done, he's given it the okay. But the failing part on the code reviewer side, 90% of time, actually, I'm not going to speak percentage. In many cases, is that he picks up the ticket, she picks up that ticket, and he just starts looking at it. Is the code nice? Is the code working? But he has no idea what the ticket actually entails. The developer, in most cases, hasn't picked the ticket up to see what does this ticket supposed to do. So as a reviewer, we should always look at the ticket, read the description. What is expected of me, of the developer? Once you understand that, you need to test to see if it works. But I'm not a QA. No, you're not a QA. But how on earth are you going to review a ticket code if you don't even know that it works? This is something that the developer should also do. So finishing here, always keep in mind that you should also question everything, even if it's your code. Because, and I'm not talking about literally every single letter, but question why is a for each being used, and for on every iteration it's pushing back to a variable, pushing back a variable to an array. Why isn't map being used, for example, or anything? Just question, like, why are things there? And since the developer side of things are finished, there's actually, no, it hasn't finished, because we do have a couple more things to do. But we will be looking at the actual pyramid of testing, which is really important to the testing world. And it is for us as well, because up until a point, talking about unit and integration, it is part of our job description as well to take care of these things. So most likely everyone is aware of unit testing, but in the front-end world, we also have some other things that we should be taking care of, literally because we have a user interface to interact. We've built it, and we need to somehow test it. But before we go there, let's just think of what we need, what we're actually testing in each case. So in unit testing, many times unit tests are being written for whole components which mount everything, etc. The architecture that we'll be looking at as we proceed is that there is no logic in everything. Logic is in one place, as we've already described. However, of course, some things, even though they're logical, there's no reason for them to be in the actual state. And for example, those are utilities, helpers, and we can actually use composables as well to get these that functionality out there. And containers with an asterisk start, because we'll be looking at in a bit. But basically, all of these parts are logical parts. And those are the only things which should actually be tested, because at the end of the day, unit test, there's an input and there's an output. If we're deeply mounting components, or a component with multiple things which interact with UI, with everything, how long will it take to actually test correctly this specific kind of component? Quite a lot. Also, just to be familiar, we do have other types of testing, snapshot testing, structural ones, which will be used for dummy UI components. As previously stated, our logic will all lie in other parts of our code, but not in the actual UI. And of course, if we really need to test whole functionalities of a component, and I'm going to use the word feature component here, because those entail components of other components with containers, composables, connection to the store, we can go ahead and use component testing to have a full interaction with it. But these are quite heavy, and also they're quite cumbersome and pretty easy to break as well. Cool. So productivity tools. Has anyone used tools like Storybook before? I know some of you have. Cool. So there's quite a few things that you can do with Storybook and tools like Storybook. They're considered a component development playground. And Storybook is one of the first which came out. We do have Histoire right now as well, which is more view-oriented as well. But the reason behind this other tool, we've already added like 10 in the stack already, and we're adding another one, is because we can build actual components without any integration with our backend. We don't care about APIs, contracts, or anything. In most cases, a ticket is given, and that has a mockup, it has some requirements, and then the backend needs to go do its thing, and the frontend needs to go and do its thing. And there's usually a time where we're trying to figure out how we can implement this, but like the backend isn't ready. So this is where these tools really shine, because this is where you will create the contract for the component. And once you do, you can interact with it through that console on the bottom. And you can test it. And you actually, not even you, testers can test it. Anyone can test it. Designers can test it to see if it's pixel perfect that they love. But you can also see something else. On the left-hand side, there's like 15, 20 components there, and many more, because this is actually a library as well. Like once this starts being built and used correctly, we can use it to get our designers, our product owners to be aware of what is in our application. And as said already, they can test it. Finally, it can also be used as a way to create either integration tests or snapshot testing, literally with 2 plugins, but with no real development after that, because you've already created the mocks at this point in time, because that's the way that component usage frequency, whatever it says there, is available for us. And the second really important development tool is our own Vue dev tools. Apologies, I couldn't find the newest version to screen grab, so I've used the previous version, but there's no real difference in terms of what its capabilities are. So you can go ahead and debug components, events, routing, performance. But I also have in bold, no more console logs, and I do mean this. I see every single day console logs being added to try and understand if a flow works correctly. But remember what I said beforehand. Our business logic should be in our store. We have our actions, we have our getters. If we close in on the gap and bring all of our functionality there, then we can use our native way to debug whatever is wrong, because all of our actions, all of our mutations, if we're using Vuex, are clearly visible in our DevTools. So if we really need to console log, it won't be during this flow trying to understand what's happening, because you can get your payload there, you can see the state, you can go back in time to understand what's happening, but only if you actually have a problem in an action itself or a mutation itself. So clicky isn't working again. Clicky, there we go. And all right, so project is set up. Now what? Well, this is where things get a bit more interesting for developers, because, well, we now still need to start using the stuff, implement the stuff, and we need to keep in mind of something really important. In most cases, in our development cycle, every single week, what we're doing in some sort of way has already been tackled. That's why we have, I don't know how many thousands, millions of NPM packages. That's why we have principles, design patterns and principles, which are there because someone at some point in time had an issue. They sat down, they figured it out. It was promoted, got acceptance, and I was there. So what I'm leading to is, when we have an issue, try and see if this actually is a new issue, or if it's something which has already been put out there through a library, principles, or patterns. And if you're not aware, ask someone more senior. Maybe they will be able to help you. But why am I saying this? What does that mean? I'm not going to write code the way that I want? No. The code, the idea, is the developer itself. The principles are there to show you a more correct way on how to get your code to be more readable and steer away from potential bugs that you may find later on. So now, since we gave a brief on why that presentation was there, we're going to be looking at a few patterns which are a crucial part of the architecture that we're discussing. And the first one is the component container pattern. Previously, I asked Ivan a question, and I expected the answer, but like, you have the man itself, so you have to ask. And that is, do composables and scope slots still have a reason to coexist? At least in this architecture, there is 100%. Why? Well, the component container pattern was introduced, I think, like 7 years ago. And it's there to decouple UI from logic. It creates an abstraction layer, basically, between what will be rendered to the browser and what is your actual logic. But why is that in place? Why do we need that? Why do we need another layer? Like, we've already have 15 tools already. We're adding this layer. We're going to add some more, actually. Well, thinking that we're constructing a large scale application, the number one thing that we need to be aware of is that since it's a living organism, things will change, either on a weekly basis or a monthly basis, but it will change. So flexibility, modularity, scalability is crucial. Otherwise, you're just going over the same code, writing duplication of code in other parts of the application. Why? Because you can't extract that to put it somewhere else and reuse it and stuff like that. So introducing a component container pattern, well, it doesn't necessarily mean that you're going to be using, you're going to be reusing it 100% somewhere. It'll definitely give you an abstraction layer between your logic and your user interface, so your UI components could potentially be reused somewhere else. It doesn't necessarily mean that this part will be reused. It may not be, and in actual fact, in most cases, it won't be. But your UI components could be. Next one, composition. Composition, again, is an integral part of the pattern that we're looking at. Why? Because in many cases, sorry, there we go. In many cases, if we do not follow this pattern of composition, what we're leading to is components which do multiple things. And that does not sit well with at least one of the principles that we were looking at, the single responsibility one. Because what does that dictate? It says, single responsibility principle, your function, your component, in our case, should do one and only thing. Our functions should also do only one and only thing, but components should also do only one thing. And I'm pretty sure you've been in code bases where you open a file and there's like 500 lines, and you need to change something in that file. And you're like, okay, beep, I don't know what to do. Well, I don't know where to start from this. And even if when you finish it, you have no idea how to test it. Why? Because, yeah, there are some unit tests there, but, okay, how do I reach this point? There's like 15 ifs and 2 fors, and this only gets called in that case, and whatever. This is where composition will really help you. You have really small parts, many small ones, but those small ones, you can just throw them away if you don't need them next day. You can also test them really easily, because if they only do one thing, it means that complexity is just on that level, whatever it is. But it's a small one. If there is one, there may not even be one. I've said this multiple times, but I'll say it again. Logic belongs anywhere else but the UI. We've seen a few places: helpers, utilities, store, but not the UI. So let's have a look at the architecture that I've been presenting all this time, and try to understand basically what we're leading to. So let's say we have a feature, the chat feature. I hope everyone can see. I had an issue. They were quite small before I had to rush and make everything a lot bigger. So let's say we have a chat feature, and that lives on a live page being whatever. What would this chat feature entail? Well, ideally, if this feature needs to be added just on this page, we can do pretty easily just by adding this chat.feature component to that page. But within that, we have all of this. What is all of this? Well, I think we should start with the store. So the store is on the right-hand side. We have our actions, state, getters. But I've also taken out helpers and utilities. Why? Well, business logic should be part of our store, but utilities are things, even if it's a calculation of adds two figures. That is a small utility, which, yes, right now you're just using it in your store, but why keep it there? Why have something which is not business related in something which is business related? But even if this is something you can't grasp, think of this. I've also drawn a line from utils to chat composable, and that could easily be to something else. For example, we had filters or mixins or whatever. But it's the same thing, but I just hate mixins, so that's why I haven't even brought them into something like this. By the way, I love composables. Don't hate me for that. So we can reuse this. Now you're going to tell me, if I move all of my logic, my business logic, into store, and from there on I have decoupled my logic from utilities and helpers, doesn't that mean that I'm making like a huge list of small functions? Yeah, you are. But what are you getting? Number one, you can test this far more easier. Number two, you can reuse this, as we are reusing in the chat composable, for example. And you could be using it somewhere else. And although this seems small, think of this. You need some kind of refactoring. The refactoring lies either in the utilities or helpers or in the business logic. And you don't have to think about where I should add this. If it's utility, you just add it there. You create the new test. It's done. It's finished. It's over. So by using this pattern, we can be more explicit on what each of these parts contain and test everything in a far more easier approach in the future, and will help us with refactoring as well. So we have our store, and we have this middle thing. I'm sorry, there should have been a title up there. I've somehow cut it out. But basically, this middle thing is the container itself. The container itself is the only type of component that should be talking to the store. No other component should be talking to the store. Only containers should be talking to the store. Those are the ones which can understand what this needs. This is just a design, but it could be broken down into smaller parts. And once it's grabbed that information, whether it's just part of a state, whether it's some methods that we need to use, for example, set user message, we can grab that and we can send it down using using scope slots, which is one of the most powerful features that I've seen in Vue.js. Now, we have a container, and going back to the chat feature, imagine that we have a chat feature and we just want to place it on the chat live page, as I said. Well, the only thing that's missing is composition of what? Well, the container, which has all the logic, and then all the various UI parts. And I've specifically left out put inside the chat header, a chat header.layout, because again, this chat header has some specific properties, but it shouldn't be it shouldn't be doing anything else other than displaying that type of component. Whether it should be narrow or not, let someone else dictate that. Why? Because if you go ahead and you add even a prop of should be bold, should be fixed on the page or whatever. Yes, you can, but you're making your component a bit more complex. And at some point, it's just going to reach a point where you're just going to have if or if. It's not necessary. It's like not 100%, but I hope you get my gist. So, finishing up with the architecture, we need to try and understand why this specific pattern is in place. Many of the things that are being used are based on certain patterns and principles, as I've already stated. These are, for example, dry. Do not repeat yourself. Super important, but do not get mixed up with do not repeat yourself in terms of logic, and do not repeat yourself in terms of I have the chat header component here, and I'm going to add it there, and I'm going to add it there. That's not repeating yourself. That's just reusing. So dry is in terms of logic. KISS. I'm not talking about the other half. I'm talking about keep it stupid simple, which we'll be looking at. Actually, let me just move on to the next slide because we will be looking at that, and I can go back to it. KISS. What does KISS have to do with ES Next, VueJS Pinia Vuex? Actually, the last part, think of documentation. The way that we can apply KISS is knowing what we're writing in, knowing our tools. That's the only way we can apply it. Why? Because, well, if I'm just getting started with any of these libraries, frameworks, and I just go ahead and start using it, writing code because I've gone in some components, see how they're done, and that's it, doesn't mean that that code was correct. And in actual fact, in most cases, may not even be the most optimal way. It was just a developer who, at some point in time, he just needed to do something quickly and just put it in, and that's it. You may be lucky enough to fall into a case where it has been applied correctly. But again, documentation is there for a reason. Read it before you use your tools. ES Next. When I say ES Next, I'm talking about literally ES6 onwards. Again, when we're using TypeScript, which I also forgot to put there, any UI framework, then the underlying language is one, JavaScript. You need to know how JavaScript is written. You need to understand the fundamentals. If you don't, there's no way you can do it. No way. Even a simple for each, as I previously mentioned, is like the most simple way of KISS not being applied. Keeping it stupid simple is a pattern which will help us reduce the amount of time spending on our code, writing it and reading it. And two more extras, which are also really important, but they're not 100%. So even though I'm saying no super duper components and no super duper functions, I'm going to be talking about only this architecture and only this. Why? Because you may be working on some kind of library where you need somehow to incorporate many things and lots of functionality. And maybe this is the only way for you to do it. I'm saying maybe because I haven't worked on one like that myself. So that, at least in large-scale applications, is a no-go, because the only thing that this will result in is tons of complexity, inability to test, and highly tight coupled components and functionality. I'll just go back a step because I missed one. Yagni. This is kind of similar to do not premature optimize your code. They're more or less the same. They're not exactly the same, but the principles basically dictates that whenever you have something to develop, as developers, and I do it myself, so I also fall into this trap, I think of how can I generalize this? How can I make this something that everyone can use? When you don't even have the requirements. You have these requirements that you're working on right now, and that's it. Everything else is a hypothesis. For that not to happen, you need a task, and that task should entail create this generic component which can do these things. The only way for us to not do Yagni and actually be working on something now is if you somehow know what the future holds. But in most cases, we don't. Sorry for that. Solid principles. I've left a couple of them out. I've left the Liskov one and the which one? The interface segregation one. Mostly because although you can slightly apply the interface one, I couldn't find like a correct pattern which I could give you and say, okay, this is how we can do it. So SRP we have discussed. I'm not going to go over that again. Open close principle is a really important one. Your code should always be open for extension, but closed for changing it. And if we think of composition as well, by the way, these the principles mostly came out for object-oriented programming, but although there's not a one-to-one, like the actual principle can be applied to front-end world as well, and JavaScript as well, actually. So think of the container that we saw before. Let me just go back. The container basically was the component. I'm talking about this one. Was the one that had all the functionality. But if we had a list, and in actual fact, we do have a list here. This could also have its own container, providing some kind of data to that one. That shouldn't be up there. It should be down here. It will use some data from the generic chat container. But there's no need to have information on a top level passing down to four of the components, all of that information. And this is where like the interface aggregation come in, because it's more or less overloading our components with information which, although can live there, if you put it there, like it could be running behind the scenes. It could be doing things that you don't even want. So try to localize stuff close enough to where your logic will actually be needed, instead of just adding top level and add the container. No, container, yes, it can be added there, but choose your territory correctly. Don't just add all your logic in one place and like have 20 components underneath just reading it. And finally, the dependency version one, which is one of the most important ones which promotes decoupled code. And it's one of the most important ones to keep abstractions where they should be. And when I'm talking about abstractions, we've already added an abstraction, but what else do we use a lot in front end? NPM packages, a lot, right? And I'm sure there have been cases that you've been wanting to change it or even upgrade it, but like you have a breaking change, or the package that you're using no longer is supported, or you need to change it for another one. So let's have a look at an example. I'm sorry, the letters are slightly small. I will try to read it out. So we have this amazing npm log package, which is written on the top left corner. And the usual pattern that is applied everywhere is that this gets exported and imported in a component, or our store, or some kind of getter, for example. And again, it's read in another component as well. Well, this is where design patterns like adapter and facade come in, and can take the ownership of the API being used. So instead of directly talking to the npm, the amazing npm log package that we downloaded and we're using, we add this adapter in the middle, which could be a component, it could be a function, it could be whatever. Like just you need to base it around its own area, basically. But what are we gaining through this abstraction? Well, amazing npm log package gets deprecated, and we can choose another one. We can import that. The adapter can read it, but our API remains the same. No the changes in our code base. And even if the new npm package that we used has far more, it has different information, this is the place where basically you will change it to have the exact same API as you were using before. Finally, as I said in the beginning, this is an opinionated way to large-scale Vue.js applications, which can be applied to other UI frameworks and libraries as well. It's not the only way, because if it was, literally it would be just one npm package, and probably npm wouldn't even exist. There are many other ways, so just keep your mind open and apply accordingly. Nothing is strict, but you just need to be aware. Thank you very much. Do I have any questions?
Hello. Is it okay to overuse state management for simple things? I mean, performance-wise, does it have any impact?
So, especially if we're using Pinia, especially if we're using Pinia, we can modularize a store and lazy load it really easily. We can do it with UX, but it's just slightly more cumbersome. If we're talking about bringing in like the new state from chat container, for example, no, there's nothing to worry about. Like the main concern that we have if we're talking about performance is not what logic is in place, but how we're crippling the browser, the user's browser through the user interface. Our components are basically the bottleneck and what starts lagging first. And if that's not the case, like if our actual logic is the problem, we can simply find it out because we have only one place to look at now. If our store is creating a problem, just profile it. And in actual fact, you'll be able to see it really easily. But overall, like even in pretty large scale applications, I have not come across such issues ever so far. Anyone else? Sorry, you want to follow up?
One more question.
Cool. Go ahead.
Thank you for the talk. The question is the following. How critical is and important is to involve the organization on these functionalities? For example, using Storybook, it's quite a good tool, but if the designers use it, it becomes perfect. On testing part, if the tickets are good, then the developers who review the ticket can do better work on it. I think it's a critical part to have the organization involved during these operations to have better results, because developers alone will struggle a lot in these 2 points, for example.
That's an excellent question. So large-scale applications are most definitely, as I've said 2 or 3 times already, a living organism. And this living organism, if you just let go of it, it will die. Every single level, regardless of if it's developers, QAs, product owners, delivery leads, technology managers, or anyone else, they should always push towards what tech is telling them is the right way to proceed. If that is not heard, the only thing that is actually being created is a ton of technical debt, which a year later is still there, and unsatisfied developers, QAs, and all the rest. So my personal opinion is speak out. No matter what your role is, if something is wrong, find a way to do it. It can't just be just a feature that needs to be implemented all the time. A feature is something else that's being added. And imagine how lovely it would be for anyone outside of the development world to have things like Storybook, for example, to go ahead and test whenever they want, whatever they want. So just push. There will always be a pushback on a change every single time. But it depends on how much you want it. If you really want it, at some point you'll get it. And I'm not saying like just grab a hold of it, but even taking initiatives to do small things by yourself on your own time, in your own time, and try to make that change and proving yourself. Like even if it means like you spend some time outside of work to get something in there, just to prove that, look, this is what we'll gain. At some point, things will shift. That's my opinion, at least.
Hello again, one more question. Is it worth it to use Storybook in case no custom design system is used and we use something like Vuetify or Quasar? Is it worth it to use Storybook in this case?
So even though we could be using something like Quasar or Vuetify or something which gives us ready-made components, you most likely still be using like custom elements, which will be creating a larger entity, correct? So those larger entities are the actual framework. You don't have to go and put in every single thing that Vuetify has, because well, they have their own storybook-like kind of tool, but and that is there for, again, designers and whoever to use. But starting to build your own library, which consists of the actual components that you are using, yeah, definitely. You can think of the rest of, like, if you think of the atomic design, you have all these small entities, which are larger and larger, until you reach a larger organism. But if the only thing that you have is the organism itself, add those to Storybook. You'll still make your life a lot easier, because product will know what you have. Testing, again, you'll be able to test everything. And even like screenshot testing or snapshot testing just becomes, will help you out if you want to change tomorrow and go to, I don't know, the next version. Anybody else?
Hey, great talk, thanks. Correct me if I'm wrong. Did you mention that it's better to have the business logic inside the store or no? I think there is a school of developers, or I thought that the opposite was the case, because sooner or later, if you start gathering your logic inside the store will become your application, right? Do we want this? Do you think it's future-proof to start gathering logic inside your store? For example, is it a good practice to start making API calls inside the store? And this is like a good way to maintain your code, especially for large-scale applications.
Especially for large scale applications, I would say it's the only way to be 100%, 99% sure that you're not causing problems anywhere else. The main reason why your store, no matter what it is, Redux, Vuex, or whatever, should be the single point of reference, is because there is one state, but there's one actual store that you can use, or multiple stores in case of Pinia. But like, there's only one place that you need to check to see what is happening. Why is my application not working? Only one place. If you don't use the store and you use like patterns, like I've even seen patterns where composables. You can create your own store using composables. But you're creating your own store using composables. You're losing all the advantages the actual store gives you, the dev tools, which may seem like trivial, but when you need to debug anything, that is what you need. Your actual development tools to see what is happening, why it's happening. And again, this is, although it's kind of off topic, they're like monitoring tools. They can use your store in their monitoring tools, so you tomorrow can go and check it out and see, okay, why did this user have a wrong journey? If we don't have a single point of truth for all of our business, it will be just scattered everywhere. No, it is. It is. Because if you don't, then any change. So why do we have actions?
I'm assuming, I imagine right now very large scale applications with tons of API calls. Should I have all these responses inside my Vuex or Redux?
Let's think of the flow. Okay. So This part is there to make the API calls.
Exactly. This is a good pattern. This is what I'm talking about. But a developer is not writing inside the state per se, like functions that they do, API calls. That's why we're reaching. Right now, it's more a modular approach. This is what I'm talking about. But you don't write code inside the state, right?
Not here.
Bring this inside the state.
Actions. Actions is a place for anything which is a side effect. So if you were talking about the actual state, no, I didn't mean that by no reason. Actions is the place. No. Actions. Actions is the only place that should make any API call and should have any kind of side effect. Anybody else?
Hi, thank you for the talk. I apologize in advance. Maybe you find this question slightly off topic, but I really wanted your opinion on views. I don't know how to exactly phrase that. No, it's fine. How does Vue and other... okay. I'll try in Greek, okay? Σε τι ρυθμό βλέπεις εργαλεία άλλα να μπαίνουν στο περιβάλλον της Vue? Για παράδειγμα, μπορεί κάποιος να ενδιαφέρεται για κλίση, για booking hotel. Εγώ, ας πούμε, ενδιαφέρομαι για χάρτες. Κάποιος άλλος μπορεί να ενδιαφέρεται για κάποιο συγκεκριμένο domain, π.χ. visualization, π.χ. ξέρω εγώ, δημιουργία γραφημάτων. Πώς βλέπεις τη Vue να έχει τέτοια εργαλεία ή τέτοια εργαλεία να γράφονται αποκλειστικά για τη Vue? Πώς βλέπεις τη σχέση αυτών των δύο πραγμάτων? Ευχαριστώ.
So yeah, it was kind of a difficult one. The question was, how do I see other libraries incorporating or having a way to incorporate tools like maps, I think was one, or graphs in Vue.js. Booking rooms and hotels and stuff like that. So thank God we're in JavaScript, first of all, because although I'm not familiar 100% for these specific types, I know that there's a Google Maps one for Vue, but like all the rest, and if you can't find anything under the packages npm, under the npm packages Vue and the keyword that we're searching for, then the data pattern is literally what you'll have to do. Create your own plugin, create your own components, but never expose directly. Because the only thing that you will do is you'll have something so tightly coupled where tomorrow you have a breaking version, and especially if it's not natively supported in Vue, that you will have to either refactor the whole thing from scratch, or it will never get refactored. Any other question? Cool. Thank you very much, guys.
So thank you, all of you, for being here. Thank you, Leandros, for your talk. Amazing talk. This is it. Thank you, everyone, for your support, for your engagement. Leandros will be available for further questions later. So again, big thanks to all of you. See you later. Bye.
you.